Hey guys, it's Brian from XS Motorworks and welcome back to my shop. So it's going to be episode 11. I only got 10 fingers. I'm not sure what, 11. Okay, 10, 11. You got it. Mini split decision. So hey, in this episode, well actually let's talk about the last episode. So I said that we were going to go to the Beater Nationals, which we did. We crushed it, sort of. What happened was we actually won 2 of the heat races. My son did a fantastic job driving. Unfortunately, in the main event, which we were leading, we actually had some mechanical difficulties and we had to retire from the race. If you're actually interested in the race, Anthony, he's probably seen him around the shop a couple of times. He's actually got it hosted up on his channel. I will put a link in the description so you can go check it out. So back to the kart itself here, what happened. So I've actually changed the clutch and put in a racing clutch. So we've got that taken care of. The diff, as you saw, is not broken, so I just reassembled everything. Threw a coat of paint on these parts that I had taken apart. Did a couple other small modifications here. So I've added a secondary tank. Really didn't even need a secondary tank. Not sure why I did it, but it looks cool. Looks much better, more appropriate. The other thing I've done is I've changed the gear ratio here. So originally I had this as a 35 tooth, and I did that to basically step down the motor because this thing only makes like 45 foot-pounds of torque, something like that. So really wanted to have some launchability, and we don't need that. Now we're going to have the electric motor going on. So I've gone ahead and changed this to a 23 tooth. So I've got the top speed now. This guy's kind of geared in the 120, 125 range, I think it was. Also in the front end, you kind of saw in the video, if you watched the video when we did the test run, we had some terrible bump steer as well as some, we actually didn't even have any Ackermans or anything like that. So I went ahead and corrected that as best as I could with the steering rack that we've got. It ain't perfect, but it's a whole lot better than what it was. We still have the crappy shocks, still need to fix that. But what we're going to do in this episode is go ahead and start putting all the electric components in. So let me actually wheel them in so you can kind of take a look. All right, so our pile of electric goodness. I got to get all of this stuff and actually even more of these batteries inside this little frame here. So what we've got is a ME1507, which is 80 horsepower, 88 horsepower, something like that, and 130 foot-pounds of torque. Don't remember the specs exactly. I will put a link in the description if you're actually interested, and probably see a banner here correcting what I'm saying. The other thing that's got to go in here to control the electric motor is the actual inverter. So this inverter's a Curtis inverter. It's a 1236 inverter, and it's got a rating of 80 volts. And the 80 volts is important because I'm going to try to over voltage it. And the reason why I'm going to do that is I've got these Carbon Fister batteries. Basically, I harvested these. They were free. They were no longer charged. And the reason why they wouldn't charge is this one cell was actually bad. It was its own pack or module. I always forget the terminology. But basically, this little unit was bad. There's about 10 of these, I think maybe a little bit more in there. And once I found that this one was bad, all the rest of them were completely charged and completely full. Each one of these, though, is 23 volts. I think that's right. Yes, 23 volts. So I've got 4 of these going in there. So 4 is going to give me about 92 volts. Hopefully, the Curtis will let me over voltage it. Not really sure just yet. Probably need to do a quick test before I actually get 4 batteries mounted in here because honestly, I don't even know I'm going to put 4 batteries in this thing in the first place. So the next challenge, though, is why don't people make hybrids? Well, there's actually a technical problem, or not technical problem, but certainly some things you must overcome, such as rev limiting in gears. So this little guy right here, he's going to try to drive this motor past his rev limiter. And the only way to correct that is if I had ability to control TPS and basically do some throttle governing on this motor and the fuel tech simultaneously. Having 2 TPS circuits. Well, they don't really do that just now, so we're going to have to basically start in second. I've gotten some re-gearing, as you kind of alluded to, and now second gear will basically be the top limit of what I've geared this to. And what do I mean by that? Well, so I've got this electric motor geared to 60 miles an hour. Then we actually have to get this thing decoupled and only rely on the gas motor. Well, how am I going to do that? Well, I found this extreme clutch, electric clutch. It's usually used, I think, in farm equipment. I read online this thing is rated to hold 250 foot-pounds of torque. So this is an electric magnet right here. It gets a 12-volt signal, and then that basically causes, this is the drive plate, and this is the basically where the gear goes. These two become mated up, and voila, we have torque coming out of this, going into our jack shaft and driving us down the road. Well, when we hit that 60 mile an hour mark, or really it's 4,000 RPMs, when I hit that on this, what I want to happen is we lose 12 volts and then this thing just becomes freewheeling. I don't want to overdrive this because I'm really not sure what would happen to the Curtis controller, because just like this thing has a rev limiter on it, if I overdrive this, I'm actually going to be putting current, I think, back through the system. It's current that it's not expecting to get. So it might actually try to bind it up. I'm not really sure. I don't want to take a chance. This stuff I actually spent money on. The rest of the cart kind of was a lot of junk that I had laying around. So I really want to make sure that I don't kind of damage this if at all possible. Well, I am lucky that the Fuel Tech does have some control options. So I've got the sensor right here, and I'll zoom in, but I've established a wheel right here, and basically I'll monitor the RPM that's on the jack shaft. Once it's in the RPM range that I like, this gang will be engaged. Basically from 0 RPM, I think I calculated it out to about 3,200 RPM given the gear ratio. And this will be engaged then on the jack shaft until we get to 3,200 RPM, at which point it'll turn off, make this thing free spinning, and allow us to continue on down the road at plus 60 miles an hour. So that should be quite fun. We'll see what happens. Okay, so what I need to do now is go ahead and get everything installed and start doing some testing. So let's do it now. Okay, so now I've got to figure out how to control the speed for both of these motors. The TPS is what's used on the gas motor, and this one right here. I've gone ahead and bought a second TPS with the same model number. As you can see, I drilled a hole in the first one, and the second one I've gone ahead and bonded a screw in with some JB weld. So now the idea is I'm going to stick the two of them together like this, and JB weld the whole thing together. And what that'll do is when I step on the gas pedal, the first one will actually start working with the TPS signal or the butterfly, which will cause the second one to go. And voila, we should have two TPS signals coming out of one gas pedal cable. Now I've got all the electric components installed. I guess we'll get a rundown of what it looks like. So here's how it worked out. So I've got the Carmen Pfister batteries, the A123, and they produce 23 volts per back. And so total, that's going to give us 92, a little over 92 volts. Those are feeding into our Curtis controller. It's right down here. And if you can read that, the Curtis actually says its operating voltage is 48 to 80 volts. So to work around that particular limitation, I bought the Curtis 1314 programming software. I got the OEM license, which allowed me to actually change that voltage to the 92 volts. This particular unit can go up to 96 at a maximum, but obviously I just have it at the 92 that I'm running. Then we take that, and all that power then gets converted into our ME 1507, and that is driven through the electric clutch. So this electric clutch is supposed to be able to handle 250 foot-pounds of torque. I guess we'll see. So the electric clutch is currently just being driven manually. I just got to plug these wires together. That is going to be driven by the fuel tech. How that's going to work is I've got this trigger wheel down here with this hall sensor, and I'm going to monitor the RPM of the actual jack shaft, and based on certain conditions, which I don't exactly know all those conditions just yet, the clutch will kick on and off. So again, looking at this, I guess, jack shaft and these chain configuration. So the chain coming off of here, we'll just kind of figure out how this all kind of works. So the electric motor, or the gas motor, is actually driven by this chain that feeds into the jack shaft. The jack shaft is actually adjustable, so this chain is kind of the first chain that gets adjusted. That comes back and forth with the slides. These jack shaft slides back and forth. The chain going here, this is going to our diff. That chain is actually controlled, as you can see down here, with these shims. So I just need to actually take shims in and out to actually control the height, and that actually impacts that chain. And the last chain over here is the electric chain, and that chain is controlled right here with this. So that touch sensor for that. So the whole system relies on this custom TPS setup. So what I ended up having to do, as you saw a little bit earlier, and this is the final product. So this is the two TPSs bonded together. Basically there's a screw that goes between there and it's all glued up with JB Weld, and that's basically working to control both of the TPSs. I think that's a fantastic stopping point for this video. The next video, we'll be taking this thing on the road and actually seeing what happens. So from me and Dead Bob, we'll catch you soon. Gas electric test, here we go. So fuel tech's coming on. The Curtis is on.
It's in forward.
Yeah, hold on, I gotta reset it. So now it's in forward. Electric.
Working off the TPS, the dual TPS.
That's both motors going.
Yeah, it stalls. The electric motor, I think, is holding it down in third gear.
Because of regen.
Yeah.
Yep.
Yeah.
Okay. All right.
So it doesn't want to idle.
Cool.
Awesome.